This quarter, I focused on designing a healing and knowledge management hub wherein all components function or interact as they would if the hub were an ecosystem, with the intention being to investigate this as a possible route towards regenerative architecture and climate adaptation. Malusi is a rapidly expanding and developing peri-urban informal settlement located about 30 minutes west of Pretoria. We started by analyzing the climate changes expected in Tshwane and Malusi and found that an increase in temperature, weather events, and eco-network disruptions are the primary changes we can anticipate. These changes become vulnerabilities when combined with the current characteristics and vulnerabilities of Malusi, such as the construction methods used or the lack of formal services. Based on these characteristics and expected changes, 6 climate risks were identified which I believe are particularly urgent to adapt to. Through our group mapping, we measured vulnerability using exposure, sensitivity, and adaptive capacity as indicators, of which I will be focusing on the latter two for this project. Specifically, I hope to reduce sensitivity by investigating appropriate ways to moderate climate changes while seeing how these options can work together to optimize their impact. I also hope to increase adaptive capacity by investigating mindsets that encourage sustainable equilibrium as a means of becoming resilient, which is where I believe the real challenge lies. In order to do this, we need to turn to nature for guidance. While investigating this concept, I encountered 3 incarnations of this kind of thinking. The first is bionics, which is copying nature in a mechanical way. The second is biomimicry, but many sources suggest that this is actually greenwash, as it relies on taking the technology of nature and appropriating it to our needs, regardless of the original context. This brings me to ecomimicry, which refers to trying to understand the intrinsic logic of nature, specifically how and why nature organizes itself in certain ways, with the ultimate intention being to understand how we can adapt our systems using this logic. This is also the theoretical framework I used going forward. Based on the literature I reviewed, I derived 7 principles that to me encapsulate ecomimicry's intentions and parameters. These underpin my design product and the design process, as this project to me was an investigation into how ecomimicry can be applied as a way of thinking when working towards climate adaptation. Underpinning all these principles is the goal of achieving resilience through networks that have many interconnections, are contextual, and have nothing unnecessary. From this, I derived an eco-mimicry-inspired strategy towards climate adaptation. Minimize redundancy, i.e. reduce superfluous components and traditional backups, and maximize contingency, a diverse system of inter-supporting mutualistic solutions towards the needs at hand. Thus, rely on resilient, interconnected networks rather than fail-safes. The first step in identifying opportunities for this entailed understanding the site and brief. For the former, this included mapping environmental characteristics and cycles, the way people interact with the site, and how these factors affect each other. Similarly, the brief from the COPC was reviewed in order to understand what they and the community need this project to be, which led me to electing healing and knowledge management as my primary programs. I also expand the clinic to include mental and emotional healing, and for knowledge management I note that it is indeed important to teach a person to fish, but it is also important that they have access to bait and tackle afterwards, otherwise their learning will be lost. Thus, both phases of learning need to be accommodated. When these two fields intersect, one also unlocks the option of helping community members reach and continuously maintain healthy lifestyles, which is a key factor in reducing climate vulnerability. Similarly, both healing and knowledge management are crucial factors when trying to address the climate risks threatening Malusi. Here we find our first opportunity for eco-mimicry. By considering the programmatic functions as component in an ecosystem, it enables us to identify the roles they play and what they need, contribute, or detract from the system in order for the whole to function coherently. But in order for this to manifest on site, they need to be overlaid with systems already present there. Thus, guided by the eco principles, I ask, what does the site, functions, and users need from this project, and how can these benefit from each other? We start off with the site characteristics that need to be responded to before identifying the core site needs, which rely on allowing ecological cycles to function uninhibitedly. But what could a function benefit from being on a specific spot on the site and vice versa? Some mutualisms are more advantageous or singular than others, and they in turn have knock-on implications on the rest of the system, which can be a result of shared needs, codependencies, or mutualisms in their own capacity. In this context, an example would be the functions that require specific services. One is then left to contemplate functions that are flexible both spatially and relationally. As such, there are several options in terms of how the remainder of the site can be populated. For the purpose of this project, I elected the indicated option as I feel it best addresses the current needs, risks, and opportunities, but this inherent flexibility was kept in mind for latter parts of the project in order to increase adaptive capacity. Thus, only the service clusters and the keystone function are fixed, with all other spaces being flexible. I propose to achieve this with modularity of materials and techniques. The 3 by 3 meter grid was selected for its near universality as a module and its advantages in terms of solar exposure, which was also a key factor in electing north-facing massing. This also suited the site shape and edge condition. Now, turning my attention to the user's needs. Firstly, this needs to be a safe yet public space for the community. Thus, passive access control was needed and achieved by nesting entrances in between functions. These entrances also streamline movement so that users can wander into the building and determine their own level of interaction. Also, spaces need to conform to their legislative spatial requirements. Intuitive movement is another factor, and by using the courtyard typology, wayfinding complications are minimized since the major functions are consistently visible. Furthermore, progress deeper into the buildings would only ever be on an ad hoc basis, thus increasing privacy as you progress. Similarly, thresholds are used to soften the transition between outside and inside, for example, or to help define different levels of privacy, which brings me to a duality that I found particularly interesting and important, namely the contrast between private and privacy, or public and exposure. This hub is notably intended as a public community space, but contained in it are zones that are inherently require privacy and an impression of safety. Thus, both need to be kept in balance. I have attempted to do so by having the main and peripheral courtyards serve to define transitional and privacy hierarchies. This is reinforced by the thresholds, materials, and the use of level differences, which in turn was informed by the site needs outlined earlier. Minimizing soil death and being ecologically permeable were two needs that I chose to address by raising the building off the ground and using pin foundation systems. This is also advantageous as the site has a slope that would have required cut and fill otherwise. It also happened to provide an interesting space-making tool and visual language for the project. I also endeavored to use techniques and materials that were mostly prefabricated while also being low-tech and standardized in an attempt to future-proof the project. The last consideration was to minimize dependency on formal service provision, which was achieved by making the building largely passive as well as by limiting services required as much as possible. Collectively, all of these considerations manifested in the building shown. The considerations and the resultant building, I believe, can be summarized in 6 strategic reactions, all of which I believe increase contingency through the principles of eco-mimicry and thus increase resilience. I will be illustrating how these reactions and considerations come together spatially with 3 example zones. First is the consultation area. Nowhere else is a public privacy duality as striking, and one can see how breeze blocks, level differences, windows, and thresholds act to ensure privacy while not alienating possible visitors. One can also see that these devices have a dual function in increasing the passive performance of the building, securing the perimeter, creating niche microclimates, or defining a visual language for the project, making it an ideal example of a high contingency system, as multiple factors contribute to the same goal, but all factors also have multiple goals, making the network as a whole more resilient. Second is the administration block. Here one can see the public street edge being used to house shops or workshops, which act as an extension of the learning taking place inside. Also, while on the external walkway, most of the site is visible, and the threshold between inside and outside can also clearly be experienced here. Modularity and flexibility are also evident here. As noted previously, I elected this functional layout as I felt it best catered for the current needs. However, if these were to change, the spaces provided are versatile enough to be adapted without changing anything structurally. However, if structural expansion was required, the modularity and low-tech construction would make this viable as well. Thirdly is the teaching nursery, which contains a variety of microclimates that would be conducive to different uses and plant life. In addition to its functional role, the nursery also fulfills several eco-roles such as increasing water and nutrient retention, biological diversity or microhabitats, acting as weather breaks and moderating temperature and humidity. I do not intend for the nursery to be a space for urban agriculture, as it is not reasonable to expect it of a nursery of this size, but rather that the worth of the nursery lies in teaching the community about the environment and about caring for plants. Secondly, I feel there is great value in allowing people to interact with and possibly form attachment to the environment through something like this nursery, as I feel this is a vital step towards true resilience. Thirdly, while we may not be able to address food security directly, the nursery can be used to study plants and thus be able to provide new information that may indirectly address food-related vulnerabilities. Lastly, I speculate on how this project might develop further to decrease climate vulnerability. This includes the hope that the community would be able to emulate feasible building techniques as well as the possibility of the hub expanding, with one possible outcome being to apply the idea of eco-mimicry across Malusi to increase the area's network resilience and adaptive capacity. In conclusion, I intended to investigate and provide the community with tools and techniques, both literal and abstract, that can be used to decrease vulnerability and adapt to the coming changes. I also believe eco-mimicry can be a great tool in changing the way we think and ultimately achieving resilient, stable networks that rely on mutualism and contingency. This is especially true in communities such as Malusi, where a small shift towards ecological thinking can have a major impact on the community's ability to adapt and flourish.